Hi everyone, so I am going to get into my third video now, going over some critiques I had when doing my research, and then also future research suggestions. And if you haven't seen any of either of my first two videos, I'll have those linked down below. The first one was on just an introduction to plastics, their abundance in marine environments, and the importance of coral reef ecosystems. Because this is about the effects of plastics on corals and coral reef invertebrates for my Master of Fisheries and Aquatic Sciences technical paper, which I'm just now wrapping up at through the University of Florida. And then the second one got into the actual effects on all those animals. And then my last one, will be on my my discussion conclusion wrap up, and also what we can do to reduce our personal waste. So I highly recommend checking out at least that one because it is important for all of us to be stewards of our environment and make an effort. But yeah, right now I will get into the critiques here. Let me just share my screen. All right. So there is obviously a big difference between laboratory studies and in situ studies, and in situ just means out in the field in the natural environment. Laboratory studies, if you're using plastic equipment, it could accidentally lead to plastic contamination of your experimental environment, which, especially for the control settings, that can lead to some issues in the overall results. And then field studies, so in situ, will experience the actual environmental variations and the multitude of environmental stressors out there. However, there is still a place for laboratory studies, and I will get more into that further down on this slide. So lab experiments, yes, they tend to lack a multi-stressor approach. Multiple stressors can have compounded effects on species, and Suckling and Richard, 2020, did a study on sea urchins, and they had 4 treatments. One was the control treatment, which is just normal, no microplastics, no low salinity. One was a low salinity treatment. Another had microplastics at high but environmentally realistic concentrations. And they had a combined microplastic and low salinity treatment. And that last treatment is the one that had by far the most significant negative effects on the sea urchins. But when you do look at one stressor at a time, you can have more of an idea of what that stressor might be responsible for in the environment, or at least partially responsible for. So the lab experiments allow for that kind of control. And then lots of laboratory experiments are short-term. Many of the experiments I saw lasted less than 1 week. A lot of them even lasted only 2 days, which is nothing, because in nature, these organisms experience a constant exposure to plastics throughout their life. They're not just going to be, it's not just going to be like, oh, 2 days, whatever, and then back away, unless they maybe live near some municipal drainage, stormwater outlet, something like that, which might, after a big storm, cause a bunch of microplastics to rush into the environment, and then those might disperse over time. But yeah, the idea of short-term lab experiments just doesn't sit right with me. And then, but some of the studies I looked at took months and they were in the laboratory, so that's better. And then microplastic concentrations. A lot of lab studies, a number of them still use environmentally realistic concentrations, and then a number of them also use really high microplastic concentrations that are above what we've observed in nature. But that does have a role. It can help amplify the effects of microplastics. So if a researcher isn't sure what effects they should be looking for, going for high concentrations at first can help them pinpoint a problem, and then they'll go use lower microplastic concentrations, more environmentally realistic ones, and look where the animal was having a problem before and see if there's still a problem there. It probably would be less pronounced if there was, but you can see, like, sometimes it is worth it doing those kinds of studies. One really well-designed study I just want to point out is this Lam et al. 2018 study. So it was out in Nature. It covered 124,884 reef-building corals across 159 Asia-Pacific reefs spanning from Myanmar to Northeast Australia. And these reefs covered 8 different latitudinal regions, so a wide variety of sample sites. And they found many similarities between the regions. This was the study that looked at the effects of macroplastics 55 millimeters or larger on coral disease, and they found that jump in disease across all those regions. However, they were the ones that found that in tropical areas, there was a higher prevalence of microbes on plastics. So doing this big, wide-scale study, you can see a lot of these trends and see if what might be something that's affecting all reefs around the world, at least all tropical and subtropical reefs, and see if there's any, obviously, issues, and there's this extra issue of microbes on plastics and being more prevalent in tropical areas. So that's something, I think, a type of study that should be done more often, or at least a study designed like that. They don't have to look at diseases, but it's just, I liked it. It was good reading. And I'm leaving all my references down below, by the way, so feel free to take a look at them. There are a lot. There are, I believe it's 42, 43, something around that. Way too many. I read way too much. But whatever. Future research. We should look into looking into the concentrations of plastic in coral reef environments, especially micro and nanoplastics. It's really hard to, a lot of people, methods can't detect nanoplastics at the moment, but we know they're out there. And then there also needs to be standardized measurement methods of these plastics, not just in the environment, but also in different species. And there's a need for people to measure the concentration of plastics in Middle Eastern reefs. We need to look more into the risks of plastics that plastics pose to reef invertebrates. This can be interactions between the plastics and organisms, the effects on them, like especially on the coral zooxanthellae relationship, or sea anemone, zooxanthellae, all those different nigerians, which also include jellyfish, which is cool and interesting. They're actually pretty closely related to corals, if you didn't know. The role of plastics as contaminant and microvectors, the travelability of plastics, and there is a need for more studies to focus on sea cucumbers, sea urchins, reef-building corals like the scleractinian or branching corals like elkhorn, staghorn, and sponges. And so I think we need to do more in situ studies when feasible, but again, like I've said, laboratory studies still have their place. And yeah, find out more about effects at realistic environmental microplastic concentrations. Look more so at doing studies on multiple stressors. Single stressor studies still have their place, but not many stressors are looking at multiple at a time, which is still important, even if it's just 2 or 3, not the many, many, many that are actually in the environment. And then the importance of this future research is for us to predict how reefs may change over time, understand how humans impact reefs, figure out ways that will be best for us to reduce our waste, and then make better management decisions. So I will leave off there. Again, my next video is going to be kind of my conclusion discussion, and we will also get into ways we can reduce our own microplastic waste. So if you have any questions, please comment below. My links to my other 3 videos will be down below, and share this to spread the word, and give it a thumbs up, which will also help this video reach more people. Thank you guys.